Live. Let's go. Yippee-dippee. Okie dokie. Right. Okay. Music. Hello, Asila. How's it going? Asilo. I called you Asila. CM, you're new. Have I seen you in my streams before? Welcome. Oh, you know what I should do? Since I'm gonna be switching between specs and can you guys hear me, or is the music too? Okay, yeah, you guys can hear me. Since I'm gonna switch between specs and programs a lot, I'm gonna do Zillage. So I'll have programs here, and then I'll have specs here. Yeah, everything works. Good, good. CPU.c, time to implement actual emulation, because last time I ended the stream after writing a giant switch case. Switch statement. Down here, yeah, this whole thing. Now I have to actually populate it. Let's see, so it ends at 692, 692, and it begins at 445. 692, 445. That's about 247 lines of nothing but a switch statement. Nice. Okay, so halt. I say halt CPU execution by setting the halt flag to 1. Halt, yep, that's what I called it. Hey, what's up, Elm? Giant is an understatement for the switch case. Yeah, yeah, that's the thing with emulators, so it's basically a giant switch case. Or a switch statement. I know some people call it switch case, but I think it's kind of ambiguous. Flags, halt, equals true. Do I need to make the music louder, or can you guys hear it? Probably can make it a little louder. Like that? Yeah, that's probably good. Yeah, guys, tell me if the music is weird and I can change it. Just a little bit too quiet or loud? Okay. I want to do that in YouTube, though, so I don't change the music. Oh, so good. What do you mean MGR? Oh. Right, that means I'll probably not like it, but... Yes. Oh. This? Okay, sure, I'll play this. Rock's fine. It does kind of get on my nerves, like, the voice, it makes me feel not so good. Yeah, I'm starting to get nauseous. I'm gonna play the other music. I'm very sensitive to sound. Yeah. I don't want to copy the emulation settings on each execute, so I'll say const emulation settings restrict settings. CPU H type def struct emulation settings. Emulation settings. Settings for emulation. Throw it back. What is your language? Asilo. Was. Bangladesh? I assume, right? Like from Bangladesh? Ah, very nice. Let's see. uint 64t waste clock cycles. Or no, I should say knop wait. Oh wait, I have knop defined. Let's see, how do I want to do this? Let's see. Well, if it isn't my favorite Gentoo user, one day I'll create incursion. Yeah, do it. Install Gentoo. Also, welcome back, Raphael Teogines. I don't know if I pronounced that correctly, but I do my best. Oh, you know what I could do? I could do, uint64t knop sleep millis. No, I don't like that. I have an idea. So instead of this, what I'll do is yeah, so I'll add a thing to my... Should I install Gentoo on my Chromebook? I don't use it. Yes, install Gentoo to it. Free it of the terrible bastard that is Chrome OS hardware. special registers. Yeah, there we go. Yeah, so I'll add a special register called knop or NP or knop waste NW NC. Yeah, NC. Yeah. Read only. It's gonna be I guess this could be 4 bytes. Yeah, 4 byte register. And this will be A, B, C, D, E, F. Oh, shoot. 0F. Knop cycles. I wouldn't use, yeah, Chrome OS is based on Gen 2. I would not use Portage on it though, since it's like a heavily modified version of Gen 2. A register that holds how many more clock cycles the CPU should waste when the knop flag is 1. Gets decremented after each cycle waste. When it hits 0, the CPU will set knop to 0. A register that holds how many, yeah, okay. The knop flag gets set to 0 as soon as the CPU sees that this register holds 0 in it. AKA no more cycles to waste. And now I actually need the knop flag. Actually, I don't need a flag. Actually, yes, I will do a flag. I'm trying to think if context saving will ruin this, but no, it won't, because there's also a register. Yeah. When set to 1, the CPU wastes clock cycles. The amount of clock cycles is stored in the NC register. Right, I called it NC, right? Yeah, NC, knop cycles. And then I need to edit ISA for knop. Set knop flag to 1 and write 1 to NC register. Waste 1 cycle. Right? Yeah. Knop I, set flag to 1 and write N to the NC register. Set knop flag to 1 and write N to NC register, where N is the immediate passed in. Waste N cycles. Yep. Set knop flag to 1 and write N to NC register, where N is the value in passed in register. Set knop flag to 1 and write N to NC register, where N is the value in passed in register. Yep. Boom. Swimming by Flawed Man. I'm probably just gonna keep my music like this. I don't know. I'm enjoying this music. I don't want to fiddle too much with it. Let's see. I should add, yeah, if CP, I can actually put this here, or no, under here for safety. If CPU dot flags knop, I need to actually add those new things too. Flag knop, right, comes after halt. Yeah, halt then knop. Bool knop. And then I need to add the special register, spreg, NC. Yep, it's after WA, WANC, good. Special register enum, special register sizes, 4. Right. Yeah, 4 bytes. How can I pad this evenly? There we go. Okay, so 88888, 18811, 8888884. Yep, it's correct. NC Uint64T NC. Yep, okay. And then I think I need to change some functionality in here too after this. CPU dot if CPU registers special NC is equal to 0, then CPU flags knop is equal to false, else CPU dot registers dot special NC minus equals 1. And yeah, so if the, yeah, okay. Right, so first I'm gonna add spreg, yeah, spreg, yeah, so spreg NC. Am I doing spreg anywhere else? Or is it just, yeah, okay. And then I need a flag case flag knop return bool pointer reference CPU flags knop. And now I'm going to write in my specification. I'll make a dedicated thing. Knop. Knop is where the CPU is instructed to waste clock cycles. The way this is controlled is via a flag called knop and a register called NC. When the knop flag is set, the CPU does either one of two things and doesn't execute any and skips instruction execution for that clock cycle. Oh wait, the CPU does either one of two things. Behavior 1. If the way this is controlled, when the knop flag is set to 1, the CPU does either one of two things. If NC register is 0, the CPU will set the knop flag to 0 and continue executing instructions instead of skipping. Behavior 2. If NC register is not 0. The CPU will decrement NC by 1 and then skip instruction execution for that cycle. Yeah. I think that's good, right? I think that makes it pretty clear what a knop is. Knop is where the CPU is instructed to waste clock cycles. The way this is controlled is via a flag called knop. And a register called NC. When the knop flag is set to 1, the CPU does either one of two things. Behavior 1. If NC register is 0, NC equals 0. The CPU will set the knop flag to 0 and continue executing instructions. I don't know. I didn't hear any playing. And continue executing the instruction instead of skipping. Behavior. If NC register is not 0, the CPU will decrement NC by 1 and then skip instruction execution for that cycle. So if NC is 1, it will waste 1, yeah, okay. NC is 1, it will decrement. And then NC is 0, it will continue. Good. Good. Okay, knop is now defined. Yeah, so if CPU flags knop, handle knop. if CPU flags knop, if CPU register special is equal to 0, flag CPU, yep, else CPU register special NC -1, return. Good. And for the knop instruction, it's just CPU flags knop true, CPU registers special NC 1. Right, I actually need a way of getting instruction arguments. Right, okay. Let me think. Hello, Darkray, how's it going? Oh, you know what I could do? I could write a function, and it will be something like, uint32t. Let's see. uint32t cycles instruction get arg uint32t, and it will take in a const reference to instruction, so instruction, and a start. Start will be 0. And I also actually want to add M32 as a type in my ISA. Yeah, assembly is definitely very fun. I think the coolest part about assembly is it's not actually a language, it's a family of languages. Immediate data. 32-bit, and integer really 32-bit. I guess I could just specify this all in one. I wonder if it's possible to make a parser in assembly. Oh, yeah, I mean, assembly is Turing complete. So, by the way, this is not Vim, this is Helix, and then I'm also running Helix inside of Zillige. But my NeoVim configuration, this is my NeoVim configuration. And it also has the ability to view markdown files too. So if I could do like nvim virtual memory, for example, and if I do markdown preview, check this out, boom. And I can view it, and I can even view like images that I put in here and stuff. It's great. Yeah. Oh yeah, and I'm also using noise.nvim as one of my plugins. But Markdown Preview is a plugin that adds that. I have kind of a bloated NeoVim configuration, which is kind of ironic considering I love the minimality and out-of-box working of Helix. I guess I'll also add IM16 and IM8 while I'm at it. Immediate data. A 16-bit integer, really. Byte, yeah. A byte of data. And since this aligns perfectly, I probably might as well do this. Let's see. An 8-bit integer, really. Boom, look at that. It actually aligns. That's kind of funny. Now I'm gonna change these no-op things. So knop I should actually take an IM32. And you know what? Let's see. Yeah. So actually, oh, never mind. I have memory address in here as a 6 byte value, 48 bits. So that's all good. Now I just have to recalculate the size for these instructions. Which, okay, so halt is 0 bytes. Knop is 0 bytes. Knop I is 4 bytes. Okay, so the new size is 4 bytes. And they're in family 0. Cool. Yeah. Well, it just depends on the emulator, I guess. Really, the only important part of the emulator is that it can emulate the instructions of the CPU and components like the MMU. But yeah, more advanced emulators have things like BIOSes and stuff, and you kind of do need that for modern operating systems running in an emulator. I definitely plan on having like a stock BIOS implementation for this emulator, but it won't be baked into the emulator. You will instead, I'm thinking, instead of saying like Oca64-emu-x and then binary file to emulate, which is currently how I have things set up, I'll probably instead force the user to make like an emulation project and then emulate that entire project. I don't know. Maybe I'll just have flags, because I want to keep it simple for the user too. Yeah, I'll just have flags. So like -x for the binary you want to emulate, and then -b for the BIOS file, something like that. Yeah. And honestly, actually, if I really wanted to do things properly, I would have you could create a new virtual disk image with the emulator, allocate some bytes to it, and then you would use the emulator to bake data into that disk image. And then, after that, you would, instead of emulating a BIOS and a binary, you would pass in the BIOS and the disk image, and then the BIOS will read the virtual disk image. So that's, I think, how things would be done properly. But yeah, so hello Noah, how's it going? Welcome, Spectrum. We're discussing emulator specifics. So like, how the emulator should be interfaced with. Yeah, I'm glad you think it's smart. Hey Theo, what's up? Also, guys, I was helping Maga with choosing a keyboard, and the one I recommended was the Rini 75. This was one of the ones I recommended. I also recommended the one I got, which is the Cedu V75, but that one has ugly keycaps that I changed out. I'm thinking, should I get myself a Rainy and then customize it? I kind of want to build another keyboard. Because my current keyboard's in light mode, and I really like it, but I also want a dark mode keyboard too for, like, late at night. Because even though it's not shining light, it's still the mood. Very sensitive to colors. It's like this. This looks really nice. I really like that. I'm not too fanatic about the sparkling back. I kind of like this more low-key gradient. You like, yeah, my keyboard. Yeah, so this is my current keyboard. I like more retro stuff. Yeah, so it's a Cedu V75 with custom, well, just keycaps I found on Amazon. So I liked these keycaps, so I got them. And this is the Cedu V75 out of the box. I got the pre-built because for whatever reason the pre-built has a knob, whereas the build-it-yourself has a screen that barely works. But yeah, so this is the Cedu V75 and its keycaps look god-awful, but you can easily change them out. Toast. The only problem with the Cedu V75 is it seems to have issues with things like VIA, so I haven't been able to configure it. Yeah, you're welcome, I guess. I personally don't like that much of a contrast, like Rainy 75. I like, yeah, like this. I'm not a huge fan of this. I mean, this is kind of nice because it's not like stark white, stark black, but let's see if they have some others. Like this, I don't like this. It looks kind of weird. But, yeah, I mean, some people like it. I feel like I'd really like this if it was, like, cyan instead of pink, just some sort of blue, and also had, like, slightly translucent keycaps. Now, that would be super cool. I have friends who own Wootings, and they say that, like, they suck. Yeah, like, these really do look kind of cheap. Yeah, this looks like the shit Razer keyboards, to be honest. Like, I can tell it's made of cheap plastic just by looking at the picture. I mean, you can make a Wooting good, but, like, for me, keyboards absolutely matter. Keyboards absolutely matter, dude. Like, I have a great keyboard, and I just don't enjoy typing on laptops anymore because it is so good. A Keychron. That's another thing, is don't Keychrons also have, like, cheap plastic exteriors? I mean, it looks a little more premium. But I do, like, the low-profile keyboards are really weird because it's, like, proprietary. Like, you can't change out the keys or something. That does look kind of cool though. Kind of like that. I do need a new wireless mouse. Yeah, see, it's like, it looks more premium than a Wooting, but I can still tell that it has like a plastic exterior. A Linux, let's go. Yeah. Yeah, if you just need like a small keyboard that's light and portable, I guess a Wooting could work. Yeah, like keyboards matter to me because I spend most of my time on a keyboard. When I'm like, yeah, that looks cool. I like that. Yeah, so this is yet another company, like their cases are really cheap looking. Actually, no, these do not look that bad. I can still tell they're made of plastic, though. It's like... there are very few mechanical keyboard companies that use metal, which is kind of sad. The keycaps on here look really nice. They do look kind of cheap, but they do look quite nice. I like that. I can't use split keyboards because I type weird. Oca64. I mean, plastic keyboards can sound nice, absolutely, but they're just... they just don't look as nice. They don't feel as nice to carry or to touch. This keyboard does look really nice, I gotta admit. Especially this one. I don't know why. I like... It sounds a little clacky, but yeah, it's not bad. Yeah. I like this yellow tint. Call me crazy. Any good thin keyboards? Not really, because it's not really what I'm into, because it's usually quite a proprietary ecosystem around low-profile keyboards. Okay, so that is the ISA. Yeah. UN32T cycles. Instruction get arg. I should probably make a separate file for instructions, to be honest. Then I'll include in here. But first I'll just finish this real quick. CPU, flags, knop, cycles. Well, the reason I am not doing fixed size instructions is because then I would have 12 bytes each for each, well, actually, since I slimmed down my memory addresses by 2 bytes, then I would have 10 bytes for each instruction. That would be, like, that would be, for 100 instructions, that would be 1,000 bytes. That is insane. Plus, I think I'm doing it just fine. Like, I don't have a specific size for each instruction. I have sizes for each instruction family. So it's like my previous architecture. To get the size of an instruction, I'd have a giant match statement. Here, I just match on the family of the instruction. Boom. And now that this is decreased, I can do that. And now, let's see, I'm going to make a touch instruction. Yeah, instruction dot HC. Instruction dot H, instruction dot C, CPU dot H, CPU dot C. I don't know why I did it like that, but oh, whoops. Okay, so now, CPU.h, instead of defining instructions and stuff in here, I'm going to define them in there. Yeah. Okay. Yep, there we go. And include stdint.h. So all of these can get chucked into instruction.c. Include instruction.h. Bool. We need a std bool. Right, and stddef.h. And that should be it. Boom. So now I need instruction get arg. So instruction h, I'm going to make a function get n arguments from instruction. Actually, I'll make that a static inline later in the C file. Get 1 byte instruction from arguments. Get 1 byte argument from instruction. This will return uint8t instruction get arg uint8t. Const instruction get 2-byte argument from instruction. uint16t instruction get arg uint16t. Const instruction get 4-byte argument from instruction. uint32t instruction get arg uint32t. Const instruction get 8-byte argument from instruction. uint64t instruction get arg uint64t. Const instruction get n-byte argument pointer from instruction. uint8t instruction get arg byte array. Const instruction. Oh, I should also have a uint8t start pose. Yeah. Like that. And here I should say uint8tn size tn. I guess this could also be uint8t. N bytes. Start bit. Start pose. Bit. Yep. Okay, now to implement all of these. There we go. uint xt value. Downloading Helix to try it out as I watch. Awesome. I guess I don't need this parameter here. Start byte, and these should all be called start bytes too. And these will all be restrict. Return instruction dot or instruction args start byte. Let's see, const, yeah, const. What is this type? Okay, so that's good. Return instruction get arg byte array instruction start byte. Hold on a second. Aha, okay, that works. Now I just need to, I actually want to remove restrict from these because I see some possible flaws. Yep. 16, 32. 32, 64. 8, 16. So 8, 16, 32, 64. Good. And I just realized I should also do a cast in here just to make sure. Size T. Helix is nice, especially with inline diagnostics enabled. The lack of plugin support at the moment sucks, though. Yeah, that's true. Okay, so that's instruction stuff implemented. Oh, I hate this. Right. C has this stupid ass thing. Is there a way around this? No. Yeah, I just kind of have to do this. Oh well. That's fine, honestly. And then for knopper, CPU flags knop true. And uint32t cycles is equal to CPU registers uint16t register ID. Instruction get arg uint16t. Instruction 0. Uint 32t cycles CPU get register pointer from ID. CPU get register pointer from ID. Register ID CPU. Fucking hell, just dealing with dumb Apple issues. Apple locked my Apple ID for no apparent reason and then had 15 servers before I was today years old when I realized that at the moment I have a different meaning. It has a different meaning. Oh, your Apple. Dude, Apple ID. Apple ID. I sniff Apple user. Eating a little bit too many apples, I see. Yep, Apple retardo. I just realized, yeah, I'm not going to expose this because it's too error prone. Get register value from ID. No, I want to expose it though, because CPU get register value from ID. CPU get register value from ID. CPU registers special NC cycles. Right, because it's a switch case. Okay. CPU get register value from ID. I also do want to spread this out a little bit. Okay, time to write this function. First, I'm gonna define it in CPU H. But I ain't gonna sell perfectly right now. Wait. Why are we spending so much time on knop instructions? Because I want to get it right. I want to get it right, that's why. Also, this is pretty standard. I'm just figuring out the ISA. I want the ISA to be super verbose and blatant. So I'm just making sure that even a dumbass can understand it. So I'm also doing extra processing in my head. Because one thing that sucks is when specifications aren't specific enough and then you have deviations. I should say get register value from register ID. Get register value from register ID. Oca64 CPU get register value from ID. Const CPU restrict CPU uint16t ID. And honestly, this doesn't have to restrict the CPU. Const CPU, yeah. Do you even know what the restrict keyword is? Of course it's going to help. The restrict keyword can literally like trim down your code base by 50%. Well, your compiled assembly instructions. Because it's essentially promising the CPU that you will not access the pointer with like any... Basically, it's promising the CPU that only that function parameter is going to point to the value. Or, yeah. It's basically... It's like C++ unique pointer, I think. I've never used C++ unique pointers, though. So, don't quote me on that. Yeah, exactly. And it's just good practice to use it wherever seems reasonable. Wait, why am I going all the way? I'll put it up here. static inline get register PTR. Static inline void const CPU. Hello, MAGA. Welcome back to your other account. Switch ID. Yeah, that's part of it, and also I just don't want you guys saying it because it's just not a good look for the server either. Because like I get that you can freely call black people the N-word in France and they don't seem to care, but like here in the U.S., like I could get killed if I go out in the street and say the N-word. It's just not a good look either. So I'd prefer if you guys did not say it, even in the degenerate chat channel. And that's another thing. I also don't want like people angrily DMing me or just leaving simply because of that. Yeah, well, you're lucky to find people like that. But also, especially down here in Texas, it's actually, like, it seems counterintuitive, but Texas is one of those states where you absolutely do not want to say it. Because even Mexican people will get offended. I've seen it happen. Yeah, look, I just don't want to deal with enforcing it and whatever. Is Oca open or no? Well, currently I'm working on it, so the specification is not online yet. But once the specification is fleshed out and I have a working emulator and stuff, I'd like to put it on GitLab, yeah. Yeah, I was using my 4th alt account when he said that. Dude, you have so many alt accounts. I would maybe wait until Jai is actually open to everyone to start writing tooling in Jai, just because, you know. Also, it's like Zig. How do you know Jai is actually going to come to fruition? Like, Zig still has syntax that's changing, like core changing syntax. And yet people are still writing stuff in Zig. I once had to try and compile a Zig project recently, and I couldn't compile it because it was using an older version of Zig that my compiler just didn't support because it wasn't backwards compatible. Your main one is a silo, I'm guessing. A 3DS, but that sounds pretty fun. See, MAGA, I know you way too well to, like, you have fun trying to fool me with your alt accounts. You just can't do it. Because I somehow know all these random things about you. Yeah, MAGA is also easy to spot. Like Game Master, I know that's your alt because you've used that profile picture before. Right, registers, let's see. We got case. I'll write some code here. There we go. If ID should actually be uint 8t. CPU H. Yeah. CPU C. Yep. And if ID is more than or equal to 0xF0 and ID is less than or equal to 0f9. Actually, I'll write this future proof. This code is future proof. If more general purpose registers are added, this code will just work. Return CPU registers general. Pointer arithmetic. How fun. Size t of ID minus f. Const. Yeah. Okay, yeah, so if, yep. Yeah, okay, that works. Wait, actually, there we go. Yes. And then switch. Switch ID. Special registers. There we go. So case case 0x00 return CPU registers special IP. Wait, I think I actually wrote functionality for this already. Like, it was, yeah, get special register PTR. Get special register PTR. What books did you read about processor none. I don't really read books. I just do all my research with online resources, and sometimes when I need to search something up quickly, I'll either use YouTube or I'll just ask an AI. Now, I never ever copy AI code because I think it's disingenuous and completely defeats the point of programming, but I do use AI to do mass web searching. If you want a good book, go read Digital Design and Computer Architecture 2nd edition. Well, I'm glad you think I'm a badass. Definitely start when I say that I do use AI, but I only use it for searching stuff up because search engines are just awful. If search engines were better, I probably wouldn't even use AI. Okay, hold on. I need to review that again. CPU, let's see. So here are my registers. 0, 1, 2, 3. I just want to verify 0, 1, 2, 3, 4, 5, 6, 7. SR is 7. Is that special registers? Okay, so it does just work. Cool. Sort of. Actually, no, it does just work. Cool. Okay. Yeah, because I got 10, 11, 12, yeah. So I'm going to do some quick and dirty C stuff. Return get special register PTR. CPU special register ID. Yeah, because it will be the same as the enum. And I am going to restrict this CPU since I have restrict listed in that other function. And that means I'm also going to restrict this CPU and restrict this CPU. And that means adding restrict to my definitions here too. Restrict. Restrict. Get register value from ID. I should also do some checking here, some bounds checking to make sure I don't or not bounds checking, but just I want to make sure I don't accidentally dereference more bytes than I'm allowed to. So I also have to if I'll write a function here, static inline const bool, or static inline bool is register ID for general purpose. Is general purpose register ID. Is general purpose register ID. Also, okay, I want to listen to this again. Cool. I'm currently reading Computer Architecture, a Programmer's Perspective, and wanted to create my second processor with pipelining, virtual addressing, and other fun concepts. Designing the ISA is overwhelming. Yes, so yeah, designing your first ISA can be kind of overwhelming, but after you design your first one is pretty easy. And building the emulator is the fun part. What I would recommend doing is instead of reading a ton of books, books are kind of dense and they are not visual. So what I recommend doing is going to YouTube channels like this is a really good one. Core dumped. Yeah. And then another one is I forgot what the other one was called, but it was talking about how the memory management unit and paging works. This guy. Let's see, is it this guy? It was, yeah, this guy. Yeah, so these are the two of the channels I recommend. There's some others, but I forgot what they're called. Oh, yeah. Ben Eater. I recommend this guy too. I've learned a lot from his channel. Another thing that's wrong with books is sometimes books go straight to explaining the advanced topics without explaining the boilerplate first. Like, for example, do the books you read actually explain what endianness is and stuff? Because if they don't, then they're skipping past some of the most important parts of understanding how a processor does stuff. It is general purpose register ID. Oh wait, I'm doing that thing again. I can just return. So if ID is more than but less than true, yep. Is general purpose register ID. static inline uint 8t register size in bytes. If ID is if is general purpose register ID, then return size of uint64t. I should put this in curly braces actually, because I might need to change this. So why can't I type? Jeez. Return size of uint64t. Return special register sizes ID. The book that I mentioned has discussed everything from Boolean algebra through digital design and is finally simplified. Okay, so it sounds like a decent book. Let's see. What data type am I storing register sizes as? Yeah, okay. Oh, I should also write some checks here. Static inline uint 8t. No, static inline bool is valid register ID. If is general purpose register ID. I want to run some checks here. If ID minus, I'll make another uint 8t gpid equals ID minus 0xf there. Okay, and if gpid is less than general num gp registers. So 10 registers, F0 is the first register. So if there's one register, F0 would be the only register. So, yeah, this would be the correct statement. Shoot. There we go. Else, CPU, mock CPU. Memset, mock CPU. 0xff and size of mock CPU. Oh, nice. Transistor. Yeah, that sounds cool. Yes, absolutely. Streaming does that. Yeah, that's why I stream, is because I wouldn't be able to do this without streaming. I just lose motivation, start watching YouTube videos, and play video games. Well, actually, not so much play video games, just watch YouTube videos and do smaller projects. Because I do program while watching YouTube videos. Sometimes I just listen to the videos. In some cases, like with ASMR, I just listen to the videos and don't even watch them. And yes, I am one of those weird people who loves ASMR. Not the weird mouth stuff, but I do love ASMR, like just like people talking and stuff. Memset, return a special get special register PTR. Or actually, no, I don't have to do all this expensive mock CPU creation and stuff. I can just say return ID is less than special register count. So if, yeah, so same thing, okay. Right, so this is my entire function for checking if a register ID is valid. I'll make a struct too. Return value for return data structure. Data structure for CPU get register value from ID return type. Type def struct CPU register register value get return. Register get value return. And this will hold uint64t value. It will hold uint8t register size, and it will hold bool valid register ID. Register get value return. Register get value return. Register get value return. Value return value. Value dot if is valid register ID. Oh, you know what I can do actually? I can do value dot valid register ID, because C is kind of cool. C is kind of cool like that. So if valid register ID, I want to if a valid register ID, I want to I feel like I should do something extra. Yeah, okay. Get register size in bytes. Value dot. I should just set things up regardless, just to be safe. Dot value 0. Register size 0. Value for valid register ID 0. Value register size valid yeah. I could even memset no, honestly, it's fine. Yeah, it's fine. Else. Guess I don't need an else. Value dot register size get register size. Register size in bytes. Register size in bytes. ID. Value dot value equals safely dereference PTR to uint64t. Safe deref PTR to uint64t. Return uint64t. Get register PTR CPU ID. Value dot register size. And I'll make this function too. Actually, no. That could be error prone. I'm seeing issues. No, I'll do it. Touch safety.ch. Safety. End if. Safety. And I want to say safe deref ptr return uint64t, and this will return uint64t include stdint.h void ptr size ten, or actually this could be a uint8t n bytes. Dereference pointer and dereference n bytes of pointer and put result in a 64-bit unsigned integer. The second, the big-endian Boolean parameter decides which byte, which side the first byte is for. If the big-endian parameter is true, the first byte gotten from the pointer will be the most significant byte of the integer that is returned. If false, it will be the least significant byte. If the big-endian parameter is true, the first byte gotten from the pointer will be the most significant byte of the integer that is returned. If false, it will be the least significant byte. Yeah. I actually don't like this approach very much. I see too many errors. Switch value.register size. Case 1. Oh, you know what I could do? I could instead write a function that is value dot value equals deref n bytes integer. pow2. Or is it pow2? 2pow. Pow n. Pow. I want to do get register pointer. Get register pointer CPU ID value register size. And I'll write utility dot or misc dot hc. Yeah. CPU misc. Uh-huh. Oh, okay. This is already a thing. Cool. So uint 64t deref uint nt to pow. Void restrict, const void restrict. Const void restrict. Const void ptr. Const void ptr uint 8t n bytes. Huh. Yeah, huh. dereference pointer as integer of n bytes and return as integer of 64 bits 8 bytes. This function will only work correctly when n bytes is a natural power of 2, right? Natural powers of 2. One, 2, 4, 8, 16, 32, 64, 100. Yeah. That is above 0 and below 128. pow2 in range. How to write a range that includes the start and excludes the end. The math. Yep, that's what I want. That's too confusing. I can just write this better. Or equal to 1. And below or equal to 64. There we go. What monitor do you use? Do I use, it's just like a generic knock monitor I found online. It doesn't work very well, so I don't recommend getting it. Like, it works fine as long as I tell Hyperland to only do 64 gigahertz refresh rate. With it's rated 128, it just doesn't work for whatever reason. Like, even on X11, so it's not a Wayland issue. I'm thankful that the frame buffer, the TTY, doesn't use the monitor's quote preferred end quote refresh rate, because that would be terrible. Dref uint nt2 pal. misc c. If n bytes. Right, okay, yeah, so this is how you write it. Okay. Good. Now time to switch. N bytes. Case. N bytes 1. Return. Return PTR uint 8t PTR. What? What the fuck? Oh. First off, oops, I'm not even including misc.h. There we go. Case, right, yep, oh, right. 2, 4, 8. 16, 32, 64. And let me change this. Dereference pointer is integer of n bytes and return as integer of 64 bits, 8 bytes. This function will only work correctly when n bytes is a natural power of 2, that is, above or equal to 1 and below or equal to 8. MISC, yep, 1, 2, 4, 8. And then default. I'll just return the maximum unsigned 64-bit integer. There we go. But Asilo, this is not C++. This is C. AKA, I don't have IOStream because I don't need it. I have stdio.h, which in a lot of ways is actually better and faster, but not as safe. This is the undefined behavior case, I guess. So I am just returning the max value for an unsigned 64-bit integer, so it is easy to find any future bugs related to this. Yep, okay. Right, so that's that. Include misc.h. Which I think there are actually some places where I can replace, yeah, like this. Return deref uint nt to pow ptr size. Yeah. Noise 2 hours in. Very nice. Okay. Well, none of this is needed. Cool. Yes, I just really slimmed that down, and I can slim this down too. Ah, look at that. Return deref uint nt to pow PTR size. Or wait, what is this? Oh. I should write another function. Wait, let me just make sure I didn't goof up that previous one. Yeah, I did not goof it up. Okay, good. What should I call this function? I should say something like set PTR to PTR uint nt to pow to integer to uint64t. There we go. Probably the worst function name I've ever had to write, but you know what? It works. So set PTR data uint set uint nt to pow PTR data to uint64t. Cool. PTR value. Void set uint nt to pow pointer data to uint64t. Void PTR uint 8n bytes uint 8tn bytes uint64t value. There we go. Dereference pointer as integer of n bytes and set its data to value. This function will only work correctly when n bytes is a natural power of 2 that is above or equal to 1 and below or equal to 8. Yep. Void deref, void set uint nt to pow PTR. There we go. Actually, no, I'm going to copy the function signature myself because I don't like how Helix formats it. And I should make it restrict. switch n bytes case 1 case 1 dereference. You know, I could probably somehow do a find and replace on here. Well, yeah. Dereference pointer set to value. And then break. There we go. And then default, I want to Oca64 t to pointer and set it to value. This function's undefined behavior. And look at how clean that is. Nice. Deref uint nt2 pow. Const ptr n bytes, good. Okie doke. Very cool. So that's getting a register value. Now setting it. So first, yeah, I'll have this return bool. Returns true, success, false, failure. Return true. If is valid register ID is equal to false, return false. And now I want to do uint 8t size register size in bytes ID, and then void ptr equals get register ptr. Well, actually, that's, Set uint nt to pal ptr data to uint64t ptr size value, and yep, as I expected. Does it tell me where? Oh yeah, C 407. Ah. Is there a way I can, well, that's kind of a problem. There we go. I think that's what I'll do. There. It's kind of dirty, but there. Okay. I don't know if that will cause, hold on, let me look this up. When marking a pointer in a function parameter definition as const, does it just indicate to the reader, or does the compiler do optimization that may break the program if the const rule is ignored by recasting to an immutable to a mutable pointer? The const qualifier serves but its primary role in compile time enforcement if you mean rather than not. Okay. So it's probably fine. I'll fix it just so I don't have to do this, because this feels kind of yucky. 407. It's fine. Okay, yep. Cool. Let's see, so I have cycles R. Register ID. Do something actually kind of dirty. Yeah. Oh. Right. Yeah, I actually want to do Hey, what's up? I haven't seen you in my streams before, I don't think. Oh. You're one of these. Yeah. Let's see. I don't want to play that because I actually know what this is from. And I don't want YouTube to get, like, mad at my live stream, but I do actually know who you are. Okay. Oh. I'll subscribe later. Sweet. Yeah, I like to drop people subs when they stop in my stream and their channel looks like something I would actually end up watching. So, yeah. I'll drop you a sub later, though, because I have to subscribe from one of my other channels, and who knows what I'll find in my subscriptions feed. Because... why, thank you. Yeah, YouTube's really annoying, because even though I'm not subscribed to any sus channels or anything, I get, like, just people clickbaiting in their thumbnails, you know? So it's like, I don't know what I'm about to see. It's the same with, like, if you see me in my streams and I go, YouTube, it's because I want to bypass the whole YouTube recommendations thing. Because who knows what I'll find on there. Something I recommend everyone does. Unit 32 T cycles are pre-value. If cycles are pre dot valid register ID equals false. This is Boolean, right? Yep. Boolean, and if this is false, to do trigger hardware interrupt. and then load, loadr, loadi. It's not watch history, it's just recommendations, like the recommendation screen. And off camera, I do actually like the recommendation screen because usually I find something interesting in there, like something about C or whatnot. Yeah, I just did a whole C++ assignment with AI and submitted that shit because I'm lazy. Bro, don't. Come on, bruh. Come on, that just hurts my soul to hear. It already hurts enough to hear people write boilerplate with Copilot. Please don't write entire code bases in AI. Heck, it hurts my soul to hear that people are even using Copilot at all. Like, what happened to just doing the work yourself? Honestly. Not disingenuously. CPU offload. CPU offload, CPU. Well, first I actually need to get the arguments. Let's see. uint 8t register ID instruction get arg uint 8t instruction start byte I never read or practiced on my own, plus it's due tonight. Something like this. Oh, you're sending me a 0x0s. What is this? I'm skeptical to... I'm gonna open this on my phone first, because I don't know what you're sending me. I've made too many mistakes like this on stream. (8u) 4n PNG. Ah, okay, yeah, it's safe to open. Uh, 0x0st 8u 4n.png. Yeah, so you just sent me... Yeah, see, the thing is, though... Oh, look, I'm here. The thing is, though, I actually like recommendations. I just don't know what's going to pop up there. So that's why I'm a bit careful with showing them. But I actually do like recommendations because, like, I'll learn stuff that way. Like, for example, that's how I saw a video by the YouTuber AstroSam, was through my recommendations. I saw this guy, my recommendations, this was the video I saw, and that's what actually initially got me into CPU design. And fun fact, he actually showed up in my streams, which is awesome, and he's in my Discord server. Link in the description, by the way. Register ID. What am I doing wrong? Oh, right, it's this thing. Hey, that fixes it. Just got... Oh, okay, actually, that is a good way to program in C, I just realized. This fixes scope issues, too. Oh, okay. I'm having brainwaves. Holy crap. Yeah, so if I put... Yeah, so what switches is this just a bunch of labels. So if I put break statements, it fixes any scoping issues. Sweet, okay. Yeah, I'm so glad I realized that. Actually, I'm gonna write a helix macro real quick. So case I'm actually gonna rewrite the macro so it's faster, because this is a lot of casing. There we go, much faster. Boom. Load. And just to confirm, yep, sweet, it works. Load register ID, and then I want to register split path. Instruction get arg uint 8t instruction 1. And I want to do like op CPU op load, and it will be register ID, register split path, and value, or yeah. No, yeah, value. No, memory address. Address T register address T address equals instruction get arg mem get arg memory address. Two. mem. Yep, okay. And CPU. Instruction H, instruction C. I also need to review the spec. Hardware instruction. Instructions that use registers to extract memory addresses truncate the most significant bits off since memory addresses are smaller than registers. Yep. Okay, it's not in this file, it's in ISA. Instruction bit layout. Instructions are dynamically sized, with the size being dictated by the 4 most significant bits in the opcode. Yep. All instruction arguments are stored in big-endian form. For example, immediate data will have its most significant side stored first in the instruction argument data. Yep, okay. So it's big-endian. Let's see. Instruction get arg uint64t. Get arg limited. Static inline get arg uint64t limited. Return. Const instruction uint8 t start byte uint8 t end bytes. There we go. And now for the functionality. Internal function that gets n bytes from instruction arguments and instruction arguments starting at start byte and reads them as big-endian, and then stores them in a uint64t and returns it. So I got a uint64t value, return value, instruction, for uint 8ti is equal to 0, I is less than n bytes, I plus plus. So, okay, yeah. This should work. Okay, so n bytes, yep, start byte. Uint 8t byte equals instruction args start byte plus I. Yep, okay. And then value, which I do want to set to 0, just so it's initialized. Uint 64t bit mask or is equal to uint 64t byte by 8. Yeah. So let's see. Yeah, I think that should work. Value equals value bit mask or. Honestly, I kind of just want to do, no, I'll do it like this. I like how that looks. No, I don't. There we go. There we go. Now they're all guaranteed to be big-endian. Almost worked. Okay, well that's easy to clean up. Boom. Okay. I believe that's all I need. And then I actually do need address t instruction get arg uint 64t No, instruction get arg memory address. Or wait, no. Instruction get arg address t. I think I can literally just copy that. Address t. Address t. Start byte. Address t. Or actually 6. Include, is it CPU.h? No. What did I store that in? Memory.h? Maybe? Memory.h. Yeah, I think that's what it was. Let me just make sure. Yeah, that's what it was. Okay. There we go. I feel like I'm doing something wrong. Does it match? Welcome back, Noah. Address T. There we go. Get 6-byte argument from instruction. Six-byte addresses. Why? Well, because the MMU, it is just a nice balance. You still get a lot of memory addresses to play with, like way more than a typical CPU is going to even support. And yet, I found that the maximum size that I am willing to go for page table memory is 2 to the power of 12, and I only want 3 page tables because any more is just way too many, and any less just makes the page tables too big. And it just so happens to be that a 48-bit memory address can be split into 12 evenly 4 times. So that's perfect because then I can have 3 page tables and then a 12-bit page index, which works because pages are 4 KB 4 KB, yeah, something like that. Here, I can check. 4 KB. Virtual memory. I want NeoVim. Yeah. So address translation. See, I have 3 page tables for address translation, and then these last 12 bytes are directly. Yeah. And trying to find where I defined pages. Page tables. Did I really not define? I actually may have forgotten to define how big a page is. Oh, here it is. The page size of this architecture's MMU is fixed at 4 KB, 496 bytes. Yeah, 57-bit memory addresses is very funky. Right, okay, so yeah, which is really good. And also, it's even more if you consider that the MMU, in the future I will add the ability for the MMU to read and write to disk, too. Which is what modern MMUs can do, too. It's, paging. That's why, like, Linux has swap partitions, is it's partitions dedicated for the MMU. Yeah. Page swapping. That's what it's called. CPU upload mem. Static void CPU op load mem. CPU restrict CPU uint8t register ID uint8t register split path. Now I'll just make a struct for this. Register data. CPU reg. CPU H. It will be internal, so type def register struct. uint8 ID uint8 split path. ID PID P split path. PID P split path. Register. Register ID, register split path. Static type def, probably. Oh wait, because type def is language specific. Yeah. It's not like in the final assembly. If any, like, if it gets past C at all, it just gets into the LLVM IR, or in this case, Gimple, and then it's just not in the final binary. Address T address. Let's see. Memory error. Actually, no. I can just, no, I'll do memory error. Yeah. Let's see. Right, so I gotta, I have an idea. Let's see. Static inline. Get sub register pointer. Sub register pointer. Type def struct sub register pointer. Void PTR uint 8t size register subreg size subregister size. Yeah, okay. Pointer to sub-register value. Start value. Size of sub-register value. Size of sub-register. Get subregister PTR. I also should say is valid split. Is the subregister a split of a register that can actually be split. General purpose registers. Bool is valid splittable. Is valid subsplit. There we go. Static inline const CPU restrict CPU. I need, this is kind of getting long, so I'll go on a new line. And then I need the register, CPU reg. Yeah, I think that's all I need. Yeah, so sub register pointer sub PTR return sub PTR sub I should say is the register is the sub-register a split of a valid register, period? General purpose or special. Bool is valid parent register. Is valid parent register. If sub PTR is valid parent register is valid register ID, CPU reg ID and then if CPU if is general purpose register ID CPU reg.id, this means it's a general purpose register, else it's a special register. If CPU reg.split path is not equal to 0, that means that subsplit sub ptr dot is valid subsplit equals. So if CPU reg split is not equal to 0, then it's a valid subsplit. Wait, no. If the split path is 0, then it's a valid subsplit for special registers, since we're not splitting special registers. Yep. If CPU reg split path is 0, then you're fine. But if it's not 0, then it's not a valid subsplit. Sub ptr dot I guess what I could do is do sub ptr dot ptr equals get register ptr CPU CPU reg ID. Yep, and I need to remove const. I'm so glad I'm doing this in C, dudes. Like, doing this in Rust would suck. Rust is not built for making emulators. Rust is not built for making emulators. It'd suck to build this in Rust. Okay, now I have to, Let's see. Let me review my spec again. General purpose registers. NVIM hardware. Let's see. Subregisters. Subregisters, general purpose registers. By adding an L or an M after the R in a register name, you can split the register. L means split the current selection in half and take the least significant bits, and M means split the current selection in half and take the most significant bits. Selection in this context refers to the current register subregister because you can split a register all the way down to a single byte. Here are some examples. And then there are examples. Register 0, full 64-bit selection. Register 5, least significant 32-bit selection. Register 2, most significant. Register 4, least significant 16-bit selection of least. Yeah, okay. And then the schema, though. Split path, here we go. Split move count. Yeah. Okay, so first I want to split out these two values. That looks familiar. I'll keep that open. So first, uint8t split count. Split move count. I want to do CPU reg split path and 0b11. Just for extra safety. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. I guess I could just do it like this. Yeah. And then uint 8t split path split move path equals CPU reg split. Yeah, I'm gonna rename this to split because split path is kind of confusing. ID split. Register split. Okay. So split. Or actually, rather, it only matters if yeah. uint8 t split move path is CPU reg split and uint8 t 0b11. Yeah. I need to review and interrupt split. When the CPU encounters a special register with a split move count more than 0. Yeah. Split path. The split path is how the CPU reads, knows which part of the full register to target. The CPU reads n amount of bits from the significant, n amount of bits from the most significant side, where n is the amount of splits stored in the split move count chunk. And traverses along the register splits while using the current bit to track current bit to pick either least significant if the bit is 0 or most significant if the bit is 1. This is kind of a mouthful and a lot to read and take in one go, so some examples will absolutely be presented. Examples. Least. Okay, I see. So most, least. So I'm reading in from most significant to least significant. Yeah. uint 8t I guess I should actually for uint t I 0 I is less than split move count I plus plus. So if split move count is, yeah, okay. Right, so split move count, yes, okay. Right, so, okay. Bool most significant equals, split move path I, or actually no, split move path and no, uint 8t bit mask 0b 1 0 0 0 0 0 0 0 1 2 3 4 5 6 7 8. Yeah. uint8t shift left count. Shift left by size, not shift left by 8 minus, or 7 minus 1, 2, 3, 4, 5, 6, 7. But if it's here, then it's 1, 2, 3, 4, 5, 6. Yep. Bool most significant equals shift left by split move path and bit mask. Yep. Also, just to make sure this code is max portable and just safe, I'm going to do this. I'm going to wrap this in parentheses, cast it as a uint8t, wrap it in some more parentheses, and I'll say equals 1, true. Oh, I did this backwards. True, false. Then again, it should just be portable. So, okay. Let's see, so I did say in the spec, right? Yeah, so 1 is most. So 1 is most significant, 0 is least significant. So I did this right. Cool. If most significant else I want to do, I should make pointers here. I should say, wait, hold on. Yeah, pointer and size. uint8t ptr uint8t size of uint64t. Yes, okay. Size. Good. So if most significant, I have to Let's see. I need to think. Most significant. I need to just decrease size by half. Yeah, that's it. Size. No, since this is not Rust, I'll just do 2. Because the compiler will optimize this anyway. Size, yeah. Yep, okay, so, and else I need to size 2, but also PTR plus equals size. Yeah. And that should traverse down. I should set some stuff here. Sub PTR is valid subsplit true. Just to make sure that always gets set. Is valid subsplit is valid parent, and then PTR size need to be assigned. Sub PTR, PTR, PTR. Sub PTR, PTR. No, sub PTR, size. There we go. I just realized I need to set this to, actually, I don't even need to do this. Yeah, I can just, sub PTR, PTR. No, no, yeah, I'll, I will do sub PTR size is equal, yeah. Sub PTR is equal to uint 8 t sub PTR size plus, or PTR. Yes, Keyboard ASMR. Sub PT. Also, welcome. I feel like I've seen you in my streams before, but I don't know for sure. Okay, so that should be that. Yes, okay. Yes. Yep. Yeah, so you were not in my streams, but I recognized you. Yeah, see, I'm not going to make Hyperland videos, though, because that's just not interesting to me. I use Hyperland as a tool to get work done, but like ricing it. I don't know. Yeah, this is Sway NC. Yeah, if you want to poke around in my configuration, I can send it. But yeah, I gravitate more towards like super mentally stimulating stuff. I mean, Mako's fine, but having a tray with all my past notifications is really good. Yeah, feel free to yoink stuff. Yeah, I don't use Pywall, but I use I write all my color schemes by hand, so I have more control over them. But like I can do here's Gruffbox, which is what my rice comes with by default. My text editor doesn't change because that's manual, but then I have Everforest, which is what you saw, but I can also do my like branded background kind of. I can do here's Forest Staircase again. There's also, I have Solarized and Nord. I have the normal, but I also have this keyboard, which someone sent me on the internet. So, Nord Dark, Silk Dark, which is a color scheme I made. I have AU Dark. I have, what else? AU Rose Pine. And also, like, the terminal and stuff changes, too. Rose Pine, Cappuccine Frappe. Frappe. Gold, which I don't know why I made it. I think I was just bored. Black Gold, which is this. Again, made it because I was bored. I have a test theme in here for some reason. Right, because I was just testing stuff. Ooh, that's bad. Right, so gold, and then Gruffbox Bubbles Dark, because I can do CSS overriding. That's a thing in my theme system. I have Everforest Medium Dark Clean, where I can choose a bunch of different wallpapers, like, for example, underwater. Let's see, what else? I have Solarized Dark Clean. I have City, which has an animated wallpaper. I have City Clean, which is the same thing, just with the clean theme. I do actually really like this color scheme. I'll have to make a Helix theme for it too. I'm going to use Everforest Medium Dark though. I used to have a global theme switcher. It also changed the color scheme on my text editor, which is of course doing GNU Emacs, the ability to maintain all these themes. Oh, I got like an image preview wallpaper. Yeah, that's cool. Yeah, I probably could make some modifications to my script to preview the wallpapers. I might do that after the stream, to be honest. Okay, so that's register splitting. Oh wait, I missed it. No, there we go. CPU load mem, yeah, and I was writing that CPU op, right. Memory error. And then sub register pointer. Get sub reg PTR. Sub register PTR. Get sub register PTR. CPU, CPU reg. And I also need to, if CPU reg dot, no, if sub register PTR dot is valid parent register is false, or yeah, I should also make this safer by saying I want to initialize this. Well, this is fine, but okay, yeah. And just for immediate debugging purposes, I should set PTR to null and sub PTR size to 1, or size of uint64t. There. Yeah. Okay. Trying to think. CPU. Operation status. Type def struct. Operation status. Yeah, that's a good challenge. Make a GTK app. Let's see. Operation status. Hardware interrupt, throw int, trigger interrupt. Should trigger interrupt. And I'll just do static inline operation status new clean op status. Yeah, you should definitely learn a programming language. I actually do recommend learning C as your first language. I know it sounds kind of intimidating, but it will teach you so much. Whereas I think Python is actually a regression, because it will teach you a bunch of really nasty anti-patterns that only exist in Python, and that will confuse the hell out of you when you try any other language. Operation status. Oh. Interrupt ID 0. Should trigger interrupt false. And here, the process will be a bit different for you, since, of course, this would be your first language, but I recommend giving this video I made a watch. I made it so I could specifically send it to people who want to learn a programming language. Yeah, I use Florp. Finding a good web browser is so hard, man. Like, Brave sucks. And it's like, yeah. I just can't find good web browsers. Florp is the best one I've found so far. See, the problem with Chromium is then you're sending all your data to Google. Even though it's open source, it's still got, like, Google telemetry and stuff, so you should at least use ungoogled Chromium. Ugh. Do I have any more, like, just music that won't make me fall asleep? I'm considering it, but, probably gonna get my stream striked or something. There should be a package in the AUR called florp-bin. I can't verify that right now, though, because I'm on Gen 2, so... Actually, does Gen 2 have... Yeah, I use the Flatpak version of Florp. It works fine. Oh, sweet. Must have got moved in. Oh, Arco Linux, cool. Yeah, I know they have a bunch of, like, extra repositories. So, yeah. Like, don't they add the chaotic AUR or something? Sub-register pointer. Operation status. Op status. New clean op status. Op status dot interrupt ID Alright, yeah, I'll see you after that. Let's see. Interrupts. Right, inv split. No, op data. Il regus. Need to add another interrupt. Invreg ac. Invregac. When the CPU tries to access a register, using an invalid register ID. When the CPU tries to access a non-existent register that doesn't exist. Via an invalid register ID, probably. Usually. There we go. Invregac. CPU H. Interrupt invregac. Cool. Okay. Op status should trigger interrupt true. Invregac. else if sub-register PTR is valid subsplit false. Op status interrupt ID no. What's the correct interrupt? Inf split, when the CPU encounters a special register with a split move count more than 0. Inf split. Return op status okay, so now I just gotta uint64t value is sub zum uint and dref uint nt2 pow sub register ptr sub register PTR size. Right, so then, okay, so that's the value. And then memory error memory write CPU memory address I should actually be going through the CPU memwrite MMU memwrite or just CPU mem write. Static inline. Still alive. Oh, I can't make it louder. Like that, maybe? Yeah. Static CPU mem write. Write data to memory, but respect the MMU. CPU const CPU restrict CPU. And then I need, shoot, why am I brain farting? Yeah, okay. Address T virtual address. Uint 8T data. Right? Yeah, okay. Return memory write. CPU memory. Virtual address. Data. To do the MMU. I also need for memory reading. CPU mem read. Read data from memory, but respect the MMU. There we go. What did you miss? Not too much, just making stuff for the emulator. More functions and whatnot. Dude, can you imagine writing a CPU emulator in assembly? That would suck. Then again, C is, like, one line of C is like a few lines of assembly, so it's not much different. Yeah, no. Actually, technically, I am writing it in binary, because I'm writing it in ASCII. See? Like, shabby. Okay, I do have shabby. Like, I could cat one of these files, but I could also print it out as hex. CPU mem right, CPU address, yeah, data value. Yeah, fucking cool. Oh wait, the song's over. No wonder. Oh. Linus said that it was cheap. Ah, I can't go that high. Okay. Community decided it was good code. People started rolling their own distros, compiling C with their make files, and it was okay. Back in 1991. Linus said that it was open. Linus said that it was GPL. And I need to learn the song. Let's see. Yeah, I can't focus with this. How about program in C? Which one? Yeah, this one. Ariel, listen to me. Oh, languages, it's a mess. Programming in C is better than anything they got over there. The syntax might seem much sweeter, where objects and subtypes play, but things like inheritance will only get in the way. Admire C's simple landscape, efficiently dangerous. No templates or fancy pitfalls like Java and C++. Program in C. Program in C. Pointers assembly, manage your memory with malloc and free. Don't sync your app with runtime bloat. Software in C will stay afloat. Do what you want, they're close to the hardware. Program in C. Do. It's super hard to sing stuff when the song is singing. AI generated. Anyway, back to regular music. Actually, not regular music, superb music. Yes. And now I'm realizing this might be kind of loud. It's like maybe to there. Yeah, that seems good. He's throwing it back, sir. I cannot attack. He's throwing it back, sir. He's shaking it fast. Yeah. CPU. what was I doing again? Oh, yeah. CPU mem right. Okay, so yeah. It's just a wall of code. CPU mem right, CPU address value. Oh, wait. No, I'm doing this wrong. Right, n bytes. CPU address value sub register PTR size. Static int CPU mem right n bytes. Const CPU restrict CPU address t virtual memory uint 8t data uint 64t actually data and uint 8t n bytes. Static int CPU mem read n bytes. Const CPU restrict CPU address t virtual address. Uint 8t n bytes. Save me, Mario. I did some more digging, and it turns out playing Save Me Mario on my live stream actually, like, not... It didn't give me a channel strike, but it, like, struck my stream. And I think I understand now why it was re-uploaded, the Save Me Mario song. It's because, like, the original upload must have gotten deleted. Bool big-endian. Bool big-endian. Let's see, for address, no, for uint 8t I 0 I less than n bytes I plus plus I feel like I had functionality for like converting endians and stuff into values. No. Yeah, it was this. Okay, there we go. I need to make like yeah, I need to make a resolve function of some kind. Wow, this file is getting long. Here's what I'm gonna do. I'm going to, first off, to be consistent, I will flip these around. And then what I'll do is I'll write another function, static address t CPU MMU virtual to physical. CPU MMU virtual to physical. Convert a virtual memory address to a physical memory address. Translate, yeah. Address T virtual address. Return virtual address. To do MMU. Actually implement MMU and shit. CPU MMU virtual to CPU MMU translate. That's shorter and sweeter. CPU MMU translate. Const CPU restrict CPU. CPU virtual address. Physical address. Address T physical address. CPU MMU translate. CPU virtual address. Return read uint 64t. CPU memory memory error. Okay. Int restrict memory error. Physical address, big-endian, n bytes. And then int restrict memory error. Oh wait, this is writing. Write. Something seems off. One sec, let me CPU memory. Oh, I've yet to write this. I see. Physical address, big-endian, n bytes. Data. Static int write memory uint 64t memory phi dat big N. So I'll make a note of that. And yeah, that should be all. N bytes big-endian physical. N bytes big-end memory check, physical address check, uint 64t data check, big-endian check, N bytes check. Write memory. Write a 64-bit value to memory. If big-endian is true, the value will be written to memory as if it was should be written to memory as if it should be stored in memory in big-endian format. All right. Yes. And I'll implement that later. This will be int. CPU. Size. Yeah, CPU big-endian. Static inline bool CPU is CPU big-endian. Is the CPU endianness currently big-endian? Const CPU restrict CPU. Return CPU flags big. Yeah, okay. Return op status. Okay. Yeah. Another thing I want to do is make. Huh. Oh. mkdir build cd build cmake dcmake export compile commands on make. Yeah. So another thing I'm going to do is add a form of coding C++. What was it? How to add C compiler flags to C make lists.txt. Target compile options, that's what it was. Project name, private, WAll, WAir, WExtra, WAll, WExtra, WAll, WExtra, WAir, pedantic. There we go. Make. Does that fix it? Make. Uh-huh. Oh boy. CPU.C 120. I just realized I can do that. Telescope? No, I'm not using any NeoVim except viewing documents in a web browser. Like that. So actually I could close this. What is what pop-up? What do you mean? Unused parameter. Oh, come on, bro. Seriously. Is this really not allowed? You're kidding. Okay. 494. 494. Yeah, okay. uint 8t 0. Uint 8t 0, no, wait, no. Shoot. $127. Wait, 128. Wait, what? Okay, so it's actually 128. Cool. Unused function, unused parameter, limits. What the fuck? If what? Okay. If ID is more than or equal to F0 and ID is less than or equal to FF. Frick. Do I have to do this to make the C compiler happy? What the hell? Still doing it. 375. Weird. If ID, oh, I see. Okay, I was being stupid. I see. See, it's always going to be less than or equal to this. Yeah. There we go. Return type. Yeah, so okay, I think this is a good spot to stop the stream right now. I'm starting to get tired, having a hard time focusing. So that was a pretty good stream. I will see you all next time. I'll see you all next time. Bye-bye.